All right, I decided to do a video on the law of sines and cosines. This is probably the most complicated thing that you'll learn all chapter. So we've been talking about triangles up until this point that are right triangles. So the sine and cosine thing works great if we have right triangles. But what happens if we do not have a right triangle? That is often the case in real life. We don't always have right triangles. If we can get them, use them, but if we don't have them, then we got to use this new thing, law of sines and cosines. So I'm not going to go into any of the proofs of these things here. You can see those on a YouTube video linked on Classroom. But I'm just going to teach you the basics of the law of sines and cosines. So here we go, 8.6. First thing to note is this. A lot of people try to use the law of sines and cosines on right triangles, and they don't need to do that. They're putting themselves through a lot more stress than they need to. If it's a 90-degree angle, just use all the things that we've already learned. If not, we're using this. Okay, so first check to see, do I have a 90-degree angle? If I have a 90-degree angle, then I know that I don't need to use this information. Okay, so check that first. They might throw a couple of those in there in this lesson just to trip you up to see if you know when to use this and when not to. All right, first thing, if you can use the law of sines, this is definitely the easiest route to go. So always check to see if you can use the law of sines. Only use the law of cosines if you can't do this. So you can use this to find the side lengths and angle measures for any triangle in which you know two angles and a side. So you must know two angles and one side. The other thing is, like, once in a while, you'll know two sides, you'll know an angle, and then they'll give you, like, x as one of your angles. You'll find that you can use that for this as well, too, and I'll show you a couple of examples of those in just a second here. But anyways, the idea is pretty simple. With the law of sines, we got to remember that things are proportional, okay? Sides are proportional to their angles. So if I know the sine of one angle and I know its opposite side, I can set that to equal the sine of another angle over its opposite side. Okay, so that's basically all the law of sines is saying. Again, you can use it with AAS or ASA triangles. These are non-right triangles. If you have a right triangle, there's a lot easier methods to use. Okay, so let's start with one of these. For example, 1A, in your notes there, it says, first of all, draw the triangle. If you don't have it, it's already here. It's already in your notes, so I don't think you need to draw it. Then for the second part here, you know angle A and its opposite side. You also know angle B, and you're trying to find its opposite side. So we can just set this up like we've set up so many proportions earlier. So you should have good practice with this, and then just cross multiply. So let's do that. The sine of A is 78 degrees. So the sine of 78 degrees over 8 is going to be equal to the sine of 60 over x. Okay? Now it's just as simple as cross multiplying. So I'm going to cross multiply these guys. Okay? So I get x times sine 78 is going to equal 8 times the sine of 60. All right, to get x by itself, I have to divide both sides by sine of 78 degrees. So x is equal to 8 sine 60 divided by sine of 78. Now, if I do this on my calculator, again, with most calculators, I mean, all calculators are a little bit different, so you're going to have to find out what works for you. So you're going to have to play with your calculator here and see if you get the same answer. But I'm going to do this on my calculator here. So what I'm doing right now, I'm using an iPhone calculator right now. Obviously, you can't use your phones on the test, so make sure you know how to use a calculator. Find a calculator that works. But I'm just putting in the number 60, and then I'm hitting sine, and then I'm multiplying that by 8. And then I'm dividing that by, and I'm going to open parentheses, and then hit 78 sine, close parentheses, equals. And what I get is x is equal to 7.08, and then it keeps going, but I'm just going to round it to the nearest hundredth. And that's my answer. Okay, so for 1a, you should be getting 7.08. You can round that also to 7.1. Typically, I have you round to the nearest tenth, so either way works. And that's 1a. For 1b, you might want to pause the video here and see if you can do it by yourself. But I'll do it here with you as well. So for 1b, we know, in this case, this one's a little bit different because notice here that we know two angles and we know this side, but the side across from here is not given to us. But can you find it? And the answer to that is yes, because with a triangle, we know that all three angles add up to 180 degrees. So if I add 37 and 54 together and subtract it from 180, I get that this angle here is 89. Okay, hopefully that makes sense to you based on previous experience here. So for 1b, first I'm going to solve for the missing angle there because that angle is needed to work with the known side, which is 10. So now I can set this up and say, okay, well, the sine of 89 degrees over 10, why did I put an x? I don't know. Over 10 is equal to the sine of 54 over x. Okay, and then you can solve that thing out. When I do, let's see, I'm going to get 10 sine 54 is equal to x sine 89. I'm going to divide both sides by sine of 89, so x equals 10 sine 54 over sine 89. Okay, so solve that out on your calculator and you should be getting the answer x is equal to 9.9. All right, and if you're having issues with that, getting that on your calculator, definitely talk to me. I can work with you on your calculators to figure that out. But hopefully you're having some success with that. And let's keep moving here into the next example. So 2a. For 2a, this one's a little bit different because we don't know the second angle. Okay, but we do know two sides, so we can set up a proportion for this angle. So what we're going to do here is we're going to say, all right, well, I know that the sine of 63 over 12.5 is equal to the sine of some angle, I don't know what that angle is, over 14. Notice that this works as well because I can use my inverse sine to solve for this thing. Okay, so let's do that real quick. So I'm going to just cross multiply here, so I get 14 sine 63 equals 12.5 sine of x. Divide both sides by 12.5, I get 14 sine 63 divided by 12.5 equals sine of x. If I want to get x by itself, I have to do the opposite of sine. Well, the opposite of sine is simply inverse sine. So sine to the negative 1 of this whole thing. Okay, this gets a little bit messy on your calculator, but it's not too bad. You're going to solve what's inside those parentheses first. So I'm going to actually stop and do that here. So I'm going to take 63, take the sine of 63 degrees, multiply it by 14. Okay, I get 12.4 something, something, something. Then I'm going to divide that by 12.5. And I get 0.9979 something, something, something. And then I'm going to hit the second function on my calculator and hit sine, so that's the inverse sine. And when I do that, I get x is equal to 86.3103 something, something, something. But this is good enough. Okay, just do it to the nearest tenth. And that's it. Okay, so it's just setting up these proportions using the law of sines. Let's do one more like that. For 2b, the way that you'd set 2b up is we know the sine of 24 over 5.3 has to equal the sine of x over 6.8. Okay, again, just cross multiply. I'm not going to do this one out for you. Cross multiply this guy out. Okay, I guess I'll do it with you so you can check your answer here. Okay, so 6.8 times sine of 24. I guess we'll just show this all out. Sine of 24 equals 5.3 sine x. So x is going to be equal to 6.8 sine 24 divided by 5.3 all to the, so I just did 2 steps here, inverse sine. So inverse sine of that whole thing equals x. So when I do this, I get, just do this out here on my calculator. Okay, so I get, when I do this in the parentheses here, I get 0.52 something something something. I'm going to hit my inverse sine and I get 31.46 degrees, something like that. So that's what your x should equal. Alright, so that's 2b. For the second part of the lesson, that was kind of the easy part. The second part is this kind of complicated law of cosines. So notice with the law of cosines, it's essentially the Pythagorean theorem, but then we make a little adjustment because we're not dealing with a right triangle. Okay, so notice there is a pattern with all of this. What this is saying is that wherever we start, okay, that's going to be our A. So wherever we start, and this will make more sense when we do an example in just a second, it's going to be our A. Then we're going to set up the Pythagorean theorem, a squared equals b squared plus c squared if we start with A. Okay, notice that the BC, so when we subtract here, we're going to subtract 2 times BC. Well, the BC is dealing with this B and C. All right, so the same things that are on the right side of the equal sign are the same thing that's being multiplied by 2 in every case. So we started with angle B, or side B, and then we're going to multiply by the 2 by the AC, the other 2 sides, and we're going to take the cosine of the angle across from B. Now all this sounds confusing until you see an example. So once I show you an example, it should make more sense. But always refer back to this law of cosines and how it works. So you can pause the video, go backwards, and take a look at it. If you need to see a proof of why this works, there is going to be one posted to my classroom, but I'm not going to take the time to do it here. Okay, so when do you use this thing? You use it when you know all 3 sides, but no angles. Or if you know 2 sides and 1 angle. Okay? So basically, whenever you cannot use the law of sines, and it's not a right triangle, you're using the law of cosines. So let's try one of these. This should now make a lot more sense. An important thing here with the law of cosines is we always start with the side opposite of the angle that you know. You're not always going to know an angle, but they're always going to give you an angle if you're going to identify it somehow. In this case, we do know the angle. We know an angle is 125 degrees, so we are going to start with the thing that's straight across from that, the side straight across from that. So we're going to say, okay, x squared is equal to, now this is just using that law that we just talked about, the other 2 sides squared. 15 squared plus 19 squared. Okay, now we have a minus sign, and we're going to multiply 2 by those 2 things. 15 times 19. The last part of the law of cosines, and you're going to want to definitely memorize this thing or get it down onto a 3 by 5 for your test, is I'm going to take the cosine of the angle that I started with. Well, the angle that I started with is the angle straight across from x. Okay, so the cosine of x, or the angle straight across from x, is 125. So that's how you set this thing up. Now, it looks very complicated. I know it is a little bit of work, but you're going to have to just battle through it, practice it for this one lesson, make sure you can do it on a test. But this does come back again. The law of cosines comes back again in Algebra 2, comes back again in pre-calc. Okay, so it's worth remembering. But here we go. This is how we will solve this thing. So the first part, we're going to just solve like we would typically with the Pythagorean theorem. So we're going to take 15 squared we're going to add that to 19 squared. So let me get my calculator out here. So we have 15 squared is 225. 19 squared is 361. Together that makes 586. So we're going to say x squared equals 586. Notice I just did this part of it first. Okay. Now I'm going to subtract the second part here. Now this is all one term. It's all being multiplied together. So I'm going to subtract that whole thing out. When I multiply 2 times 15 times 19, I get 570. So this is going to be 570 cosine of 125. Okay, these steps are very important. You do this kind of in the same order every time, get it into a rhythm. Now for this part here, if I want to get x by itself, I have to take the square root of both sides. Okay, so there's a couple things that I could do here. I could solve the right side of the triangle and then take its square root, or I could just take the square root of the whole thing and use parentheses. So I guess I'm going to show you the first thing that I mentioned. So I'm going to keep x squared over there. So I'm not taking any square root yet. I'm going to keep my 586 here, but then I'm going to simplify this. Okay, so I'm going to take 570 and multiply by the cosine of 125. However that works on your calculator, make sure you can figure that out. But I am doing it on an iPhone right now, and it is, I'm going to put in 125, and I'm going to hit cosine. And you'll notice when you do that, it's a negative number. Okay, then you're going to multiply that by 570, and you get negative 326.938 or something like that. I'm going to show you one of the downfalls of doing it this way, but it's okay. 326.94, something like that. Okay. Notice we have two negatives there, so when we add those together or subtract those, we're going to actually get those are going to turn into a plus sign. So I'm going to add that to 586. And when I do this, I get 912.94 equals x squared. Okay, to get x by itself, I have to take the square root of both sides. So square root of 912.94, I'm going to take the square root of my calculator. And when I do that, I get x equals 30.2. Okay, the other thing you could have done is you could have used parentheses and taken the square root earlier of this whole term. So either way you do it's okay, just make sure you get a system that works for you. For 3b, I went ahead and set it up there for you already without writing it down. It was built into my slides here, so I'm just going to leave it, I guess. So for 3b, notice here that the angle that I know is 62 degrees, so I'm going to start with the one straight across from that, which is, I'm going to make my x here, or was labeled x. Okay, so x squared is equal to the other two sides, so the 7 here is linked to the 7 here, 4 comes from the other side, 4. Okay, so I'm going to, x squared equals 7 squared plus 4 squared minus 2 times those same numbers, that's kind of the pattern, times the cosine of the angle that I started with, 62 degrees. Okay, so again, I just run through this. When I do 7 squared plus 4 squared, well, that's 49 plus 16, which equals 65. So I'm going to have x squared equals 65 minus, this is all one term, so I got to multiply it all out. I get 2 times 7 times 4, I get 56 cosine 62. Okay, I'm going to simplify this again before I take my square root. So on my calculator, I'm doing 62, hitting the cosine button, multiplying by 56. And I get 26.29, not a negative this time. So x squared equals 65 minus 26.29. Okay, I'm going to subtract out that, or I'm just going to complete that operation there, and I get x squared is equal to 38.71. To take the square root of both sides, and I get x is equal to 6.2. And that is my answer for x. Okay, so that was 3b. The last, well, I guess I have a couple more examples, but this is the last major thing I'm teaching you here. Sometimes you have all three sides given to you but no angle. You still want to start with the side opposite of the angle that you're looking for. Okay, so in this case, we know all of our sides. So we're going to start with the side opposite. So we're going to get 1.9 squared equals 1.3 squared plus 2.1 squared. Again, that's just the Pythagorean theorem. Okay, and now we're adding on. Minus 2 times 1.3 times 2.1 cosine of x. You can imagine how you're going to have to get x by itself here. You're going to have to take the inverse cosine for this thing. So let's do a little bit of work here. 1.9 squared is 3.61 equals 1.69 plus 4.41 minus 5.46 cosine x. Okay, let's combine our like terms here and move some things over. So when I add this together here, I'm going to get 6.1 minus 5.46 cosine x equals 3.61. Okay, and then I want to move my 6.1 over. So 3.61 minus 6.1 gives me a negative 2.49 equals negative 5.46 cosine of x. Still trying to get that x by itself, so I'm going to divide both sides by that negative. So when I do that, I get we're going to get a negative divided by a negative here, but it's going to be, let me just do it out here on my calculator. 2.49 divided by 5.46. It's a negative divided by a negative, so we're going to have a positive answer. It's going to be 0.456 equals cosine of x. To get x by itself, I got to take the inverse cosine. So I'm going to take cosine of negative 1 of 0.456, or whatever you had stored in your calculator. And when you do that, you get 62.8. 0.87, something like that. I think they wanted you to round this to the nearest degree, so you could say approximately 63 degrees. And that's it for example 4a. For 4b, if I gave you 4b on your notes, it's the exact same thing. So I'll let you guys try that one on your own, but I don't want this video to be like 30, 40 minutes long here, so let me just keep moving on to 6a. So for 6a, they want you, there's going to be a couple of these, this is example 6, where they give you a triangle, and then they give you pieces of the triangle. Okay, you got to fill those things in, and then just use everything that we've been using. All right, so for 6a, if we filled this in here, we would get that this is 10.2. I would draw this if I were you. This is 9.3. Angle A is 26 degrees. Okay, we know two sides and one angle, which means I have to use my law of cosines. All right, so if I use my law of cosines, I should be able to find all the missing pieces of this thing. So for 6a, I'm going to do one of these with you. 6b, I'm going to kind of let you do on your own. Okay, so I'm going to start with my angle A. My angle A is 26 degrees. Across from that is 10.2. So here we go. I'm going to start off with a squared is going to be equal to 10.2 squared plus 9.3 squared, okay, minus 2 times those two things, 10.2, 9.3, cosine of 26. Then we're going to solve it down. A squared is going to be equal to 104.04 plus 86.49 minus 189.72 cosine of 26 degrees. When I do this out, I'm just going to say that A is going to be equal to, I'm going to combine these guys, the square root of 190.53 minus 189.72 cosine 26. So A is going to be equal to, when you do all this out, you get 4.5. Okay, so once I know that, I know this, but they want me to solve the entire triangle. So I also need to know the other angles. But once I know all three sides, now it's easy. I can just use my law of sines. Okay, so for these guys, you're going to have to use a kind of a combination. You could use law of cosines for the whole thing, but it gets kind of messy. I mean, do you want to do this same process over and over again? You can. If you really want to, you can use some inverses and figure it out. But I'm going to say, let's use the law of sines for the rest of this. So we know that the sine of 26 over 10.2 has to equal the, and it doesn't really matter where we start with this one, we could say the sine of, and I didn't label this thing right, I apologize guys. This should have been 26, my bad. Okay, hopefully it doesn't throw you guys off that much. Okay, so if I'm looking for the sine of 26, actually, since I labeled that wrong, sine of 26, I apologize, sine of 26 over 4.5 has to equal the sine of, let's just say, b over 10.2. Okay, so to find b, I'm just going to cross multiply, and I get 10.2 sine of 26 equals 4.5 sine b. Divide both sides by 4.5, and I get 10.2 sine of 26 over 4.5 equals sine b. And angle b is going to be equal to the arc sine or inverse sine of this whole thing. So sine -1 of that whole thing. I'm just going to kind of point it up there. When you do this out, you're going to get that b is equal to approximately 84 degrees. Okay, once you know that, I mean, it's really simple. Add that to 26, subtract from 180, and you have angle C. Okay, I'm not going to do the other one right here. Maybe I'll do it in class. But your homework here is to do page 593, 15 through 37 odds. Remember to look to see whether or not you're doing sine or cosine, law of sines, law of cosines. Make sure to look for a right angle. And have fun with this.